Alright, so in this video, I'm going to be proving to you guys that 2 plus 2 is equal to 5. So, to do this proof, what I'm first going to do is start with a true statement, that 0 is equal to 0, which is obviously a true statement because any number is equal to itself. Now from here, what I'm going to do is rewrite 0 on my left-hand side as 20 minus 20, and rewrite the 0 on my right-hand side as 25 minus 25. So now I get 20 minus 20 is equal to 25 minus 25, which is again a true statement because 20 minus 20 is 0, and 25 minus 25 is also 0. Now from here, I'm going to rewrite 20 as 4 times 5. So now I get 4 times 5 minus 4 times 5 is equal to 25. I'm going to rewrite this as 5 times 5. So I get 4 times 5 minus 4 times 5 is equal to 5 times 5 minus 5 times 5. And now, if I have something in the form a times b minus a times b is equal to b times b minus b times b, which is this form, well, notice how we can simplify this by factoring out the greatest common factor. So for my left-hand side, we have a greatest common factor of either a or b because both of them are in both terms. So what I'm going to do is I'm going to rewrite this as a times b minus b. Basically, I factored out a. Now for my right-hand side, all we have is b because that's the only term for my right-hand side. So I'll just factor out b. So I get b times b minus b. So now in the case of this, for my left-hand side, I'm going to factor out 4. So I get 4 times 5 minus 5, which is equal to, for my right-hand side, I'm going to factor out 5. So I get 5 times 5 minus 5. So now I have 4 times 5 minus 5 is equal to 5 times 5 minus 5. And what we can do over here is, if I have something in the form a times b minus b is equal to b times b minus b, we'll notice how we can just cancel these two out, meaning that a is equal to b. So in this case, I have 4 times 5 minus 5 is equal to 5 times 5 minus 5. I can divide both sides by 5 minus 5. And these two cancel out, these two cancel out, and I am left with 4 is equal to 5. Now, going back to our original equation, I said that I was going to prove that 2 plus 2 is equal to 5, right? Well, what is 4 equal to? 4 is equal to 2 plus 2. So I get 2 plus 2 is equal to 5. So I just proved that 2 plus 2 is equal to 5. And now I know what you're thinking. This is mathematically incorrect, right? How can 2 plus 2 equals 5 when 2 plus 2 is equal to 4? Well, look back here and try to figure out where I made an error. So the error is actually right here in this step where I divided both sides by 5 minus 5. So let me write this right here. I have 4 times 5 minus 5 is equal to 5 times 5 minus 5, right? Well, instead of just going on and dividing both sides by 5 minus 5, what is 5 minus 5? 5 minus 5 is equal to 0, right? So this is basically 4 times 0 is equal to 5 times 0. And then now, if I try to divide both sides by 0, well, 0 divided by 0, that is not equal to 1. 0 divided by 0, that's indeterminate. So we can't actually cancel these out, because if we cancel it out, we're implying that 0 divided by 0 is equal to 1, which is wrong. So that's actually where I made the mistake when I canceled out the 5 minus 5s. I wasn't allowed to do that because that's basically dividing 0 by 0, and that is against the laws of mathematics. So this means that 2 plus 2 is not equal to 5. So, yeah. Alright, so in this problem, I have 8 to the power of x plus 2 to the power of x is equal to 30. So I'm going to first start by rewriting 8 as 2 to the power of 3. So now I have 2 to the power of 3 to the power of x plus 2 to the power of x is equal to 30. Now, if I have something in the form a to the power of m to the power of n, this is the same thing as a to the power of n to the power of m. So I can switch the places of n and m. So in this case, I have 2 to the power of 3 to the power of x, and I'm going to switch the places of 3 and x. So I get 2 to the power of x to the power of 3 plus 2 to the power of x is equal to 30. Now, I'm going to let the variable u equal 2 to the power of x. So now if I substitute in u for 2 to the power of x, I get u to the power of 3 plus u is equal to 30. And now I can subtract 30 on both sides. So then these two cancel out, and I get u to the power of 3 plus u minus 30 is equal to 0. Now we have an equation here, and we need to find what value of u makes this equation equal to 0. So what I'm going to do to start is rewrite 30 as negative 27 minus 3. And the reason I did this is because 27 is the same thing as 3 to the power of 3. Notice how we have something in the form u to the power of 3 plus u. We could think of u as 3 in this case. So 27 is the same thing as 3 to the power of 3, and we have this minus 3. Now I'm going to put this in the form u to the power of 3 minus 3 to the power of 3 plus u minus 3 is equal to 0. So now, if I put this in parentheses real quick, if I have something in the form a to the power of 3 minus b to the power of 3, this is equal to a minus b times a squared plus ab plus b squared. So in this case, this turns into u minus 3 times u squared plus 3u plus 9 plus u minus 3, which is equal to 0. And now, because both of these terms have a common factor of u minus 3, if I factor out u minus 3, I get u minus 3 times u squared plus 3u plus 9 plus 1 is equal to 0. And now from here, 9 plus 1 is 10, so I get u minus 3 times u squared plus 3u plus 10 is equal to 0. Now this gives me two equations. I get u minus 3 is equal to 0, and I get u squared plus 3u plus 10 is equal to 0. So u minus 3 equals 0. That's pretty easy to solve. All I have to do is add 3 on both sides, and I get u is equal to 3. Now remember how we let u equal to 2 to the power of x, meaning 2 to the power of x is equal to 3. And now to solve this, I'm going to start by taking the log on both sides, so I get log 2 to the power of x is equal to log 3. And if I have something in the form log a to the power of b, I can move this exponent b to the front, so it's going to equal b times log a. So in this case, I have log 2 to the power of x, and I can move x to the front, so I get x times log 2 is equal to log 3. And now if I divide both sides by log 2, these two cancel out, and I get x is equal to log 3 over log 2. Now, log 3 is equal to 0.4771, and log 2 is equal to 0.301, meaning this is equal to x is equal to 1.539. Now, going back over here, we have u squared plus 3u plus 10 equals 0. And let's use the quadratic formula to solve this. So the quadratic formula is negative b plus or minus the square root of b squared minus 4ac all over 2a. So in this case, a is 1, b is 3, and c is 10. So I get u is equal to negative 3 plus or minus the square root of b squared, which is 3 squared, minus 4 times a, which is 1, times c, which is 10, all over 2a, so 2 times 1. And this gets me negative 3 plus or minus the square root of 3 squared, which is 9, minus 4 times 1 times 10, which is 40, all over 2, which is equal to negative 3 plus or minus the square root of negative 31 over 2. Now, the square root of negative 31, that's a negative number, so that doesn't work, meaning my only solution is 1.539.